All right, so welcome to lecture number 11. Now, in this lecture, we're going to fill in a few details about compounds and elements that we haven't talked about yet. So the first thing we're going to get into in this part A, is we're going to learn a little bit about the different types of compounds and elements. Like that mainly is going to have to do with like if we could see the particles, what would they look like? So that'll be in part A, this part. Now, in part B and C, what we're going to look at is how much do these particles weigh? So the basic particle of an element is called an atom, and we're going to learn how do we figure out the weight of an atom. And then in part C, we're going to look at, well, for a compound, the basic particle in a compound is, well, usually a molecule. It could actually be other things as well. How much do they weigh? How much do those particles weigh? All right, so with that, let's go ahead and get into this. And we're going to start off with elements. Now, when I say an element, that means that we're talking about something that's made up of only one kind of atom. It turns out that there's two different ways that these atoms might work together, though, to make an element. So some elements, and actually most elements, are called atomic elements. Atomic elements just means an element whose basic particle is a single atom. And again, this turns out to be most elements. Most elements, if we could look inside of them and see what they're really made up of, they would look something like this. So if you had like, I don't know, like a piece of copper or a piece of magnesium, something like that, if you could see inside of it with some super high-tech magnifying glass, what you would see is a bunch of single atoms kind of near each other. That's called being an atomic element. So most elements are made up of like single atoms sitting near each other. Now, that's not true for all elements. Some elements are called molecular elements. So in a molecular element, we're looking at an element, we'll say it this way maybe, whose, that's a whose there, particles are composed of two atoms joined together. Two atoms joined together. All right. It's an element whose particles are composed of two atoms joined together. So if we could see inside of it, what we would find if we had some really great magnifying glass is that it would look something like this. These guys like to exist in groups of two. So we have kind of our single atoms, that's like single people, and then we have other people, other elements that are married. They like to exist with a partner. So they would look something like this. Two atoms combined, and then there'd be another unit, two atoms combined, and then another one, two atoms combined, and so on. So in this case, the particles exist as two atoms put together. Now, there's not many of these elements that like to live as a couple. In fact, there's only 7 of them. There are 7 of them. There are 7 molecular elements. Knowing these molecular elements is going to be important. And it's not really going to be so important like in this lecture, but when we get into the next chapter and we start writing out reactions, because that's coming up in a chapter or so, you're going to have to know these or else you'll have some trouble writing out reactions. So the 7 elements that like to exist as a pair are, well, the way I remember them is you start at element number 7, that's nitrogen, so there's 7 of them. You start with element number 7, and you draw a 7. So you start at nitrogen, you go over to fluorine, and then down. So that kind of looks like a 7, doesn't it? So the 7 molecular elements are nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now, if you count, that's only actually 6 of them. So there's 1 that isn't part of that little group, and that's actually hydrogen. So hydrogen is also a molecular element. So why is this important, or how is this going to come up? Well, the reason it's going to come up is because if I ask you, can you tell me the symbol for hydrogen? Now, not hydrogen when it's part of a compound, but just hydrogen. Tell me the symbol for hydrogen. You really want to make sure you tell me that it likes to be part of a pair. So you wouldn't really want to write H. You would write H2. Now, again, let me say this again, because you don't want to get mixed up by this. I'm not talking about when it's combined with some other element, carbon, or combined with calcium, or I don't know, copper or whatever. If I am just talking about hydrogen, tell me the symbol for hydrogen. You really should be writing H2. Similar for oxygen. If I say, hey man, I got a tank of oxygen. What's the formula for oxygen? What's the symbol for oxygen? Again, it's one of our 7. You should be writing O2. So again, the same thing would be true for all of them. So all of them, these 7, again, nitrogen, oxygen, fluorine, all the way down to iodine, and then also hydrogen. Start at 7, make a 7. When we want to know their symbols, you should be writing a subscript 2 on them. Now, you see those listed right here. So, hey man, what's the symbol for bromine? Br2 really is better. And the only other thing I want to mention about this, you'll see it in this chart, sometimes these molecular elements, they're sometimes called diatomic. So diatomic 2 atoms. They like to exist in a group of 2 atoms. So whenever I ask you the symbol for one of these 7, you should have a subscript of 2 on them. All right, so that's it for the kinds of atoms. Now again, there's only 7 of them. Everybody else, if I said, tell me the symbol for copper, you just write Cu, not with the subscript 2. Hey, tell me the symbol for titanium. You just write Ti, not with the 2. All right. All right, so what about compounds? Well, there are 2 kinds of compounds, 2 important kinds of compounds. And actually, you've heard about these already when we did naming. Remember how we talked about how to name ionic compounds? Well, that's one category. And then we talked about how to name molecular compounds. Well, that's another category. Now, what we haven't really talked about is, what do these things look like? If we could see inside of them, what would we find in an ionic compound, and what would we find in a molecular compound? So for an ionic compound, just to remind you, they are always made up of a metal and a nonmetal. A metal and a nonmetal. So we're going to have something from this left-hand side of the periodic table along with something from the right-hand side of the periodic table. When you put them together, you get an ionic compound. Now, how are they going to get together? Well, the way they're going to get together is that they are, we'll say, formed by the transfer of electrons. And another way of saying that is, when you transfer electrons, when you gain electrons, lose electrons, you're going to turn into an ion. So I guess we could say that they contain ions. They contain ions. So ionic compounds made up of a metal and a nonmetal. They're formed by the transfer of electrons. They contain ions. Now, again, if we could look inside of them with some super great magnifying glass, what would we see? Well, what we would see is this. Their basic particle is an ionic lattice. So an ionic lattice is an array, so it's like a grid, that's what an array means, a grid of positive and negative ions. It looks something like this. So there would be, for example, I guess an ionic compound, one example would be like sodium chloride, like table salt. And if we have sodium chloride, what you would find inside of sodium chloride is, well, let's remember our charges. Sodium is +1 and chloride is -1. So you would have a grid, like a pattern of alternating positive and negative charges. So the green guys are supposed to represent sodium in this diagram. So we'd have our positive sodium, and then we'd have our negative chloride, and then it would just keep on going. A positive sodium, and a negative chloride. And this goes in like 3 dimensions, right? It's a 3-dimensional shape. So positive, negative, positive, negative, positive, negative. So that's called a lattice. Sometimes you might hear it called like a formula unit. All right. Now for a molecular compound, molecular compounds are different. Molecular compounds, let's switch to a different color here. Molecular compounds are, first off, you already know when you learn to name them, they're made up of 2 nonmetals. What we haven't talked about is what's going on to keep those nonmetals together. And what's going on is they are formed, we'll say, by the sharing of electrons. Formed by the sharing of electrons. And their basic particle is called a molecule. So what would it look like? Well, it would look something like this. If we could see inside of, I don't know, what's a molecular compound? One example would be like carbon dioxide, right? They're both nonmetals, yeah. So inside of carbon dioxide, this is what we would find. You would have, let's draw a little box. We would have a carbon, and then it would be connected to, maybe I'll make the red be oxygen, 2 reds. That would be a molecule of carbon dioxide. So, and you know, if you had a carbon sample of carbon dioxide, some carbon dioxide, you wouldn't just have one of these. So that's one molecule. You'd have a bunch of molecules. So they would all look identical, carbon, and then 2 oxygens, something like this. All right, so those are called molecules. So they're individual little units inside of this material. I've only drawn 2 molecules. In real life, you'd have, you know, billions of these things. All right, so ionic compounds, metal and a nonmetal, they are made up of a lattice. Molecular compounds, 2 nonmetals, they're made up of molecules. Now, let me show you one more picture of this. This is a picture out of your book. This is kind of this is kind of putting it all together. All right, so compounds come in 2 flavors. We have molecular, made up of molecules. Water is another example. We have ionic, made up of this lattice. So again, sometimes instead of being a lattice, you might hear it called a formula unit. So a formula unit is just like one of each, like 1 sodium and 1 chloride. So that would be a formula unit. So this has actually got a bunch of formula units. Every little sodium and chlorine together is a formula unit. Elements, same idea. There's 2 kinds of elements. You can be an atomic. Atomic things are like your loners. So most elements are atomic elements. And then some elements like to exist in a pair. They like to come as a group, and those are called molecular elements. And again, there were 7 of those. For example, oxygen is a molecular element. All right, so with that, let's do a little practice. So if I could see the particles inside of something, what would I find? All right, so I'm going to put up a few, and we'll go over a couple of them. All right, let's do a little bit. So you should be able to classify things as either an atomic element or a molecular element, or a molecular compound or an ionic compound. So just to make sure you know, a compound just means that we have 2 things joined together, right? Sodium and chlorine, hydrogen and oxygen. An element is only containing 1 kind of atom. All right, that's the difference there. All right, let's do some practice. All right, classify each of the following as either an atomic element, molecular compound, or ionic compound. So maybe we should do a couple just to make sure you're sure. All right, so aluminum. What kind of material is aluminum? What is it? Is it an atomic element or a molecular element, a molecular compound, or an ionic compound? Well, first off, it ain't a compound because it's only one thing. It's only one element, right? It's just aluminum. So it's an element. Now, is it molecular or is it an atomic element? So aluminum is Al, and Al is right here. It is not one of our 7 molecular elements. So if it ain't one of those 7, It's got to be an atomic element. It's made up of single little atoms. So it would be like a box full of single little atoms. Okay. All right. What about aluminum chloride? Oh, let me erase that. What about aluminum chloride? Aluminum chloride. So first off, it's two kinds of atoms put together. Two kinds of atoms put together, that's a compound. Now, is it a molecular compound or an ionic compound? Well, let's look at where those elements are. Aluminum and chloride. You got one of each. You got a metal and a nonmetal. What is that? Oh, that's ionic. That's an ionic compound. So if we could see inside of it, we would see that repeating grid of positive and negatives alternating over and over and over, that three-dimensional grid. All right. All right, there's two more on here. I think for these last two, we should do a little practice. Let's see if you can figure out chlorine, Cl2, what the heck is that? And how about carbon monoxide? What the heck is that? So we're going to do some little pop-up questions here. So they should pop up here in a second. Cl2, what is that? And how about carbon monoxide? What is that? All right, hopefully got those two right. You could tell me what kind of particle is inside of them. If not, you can ask me during our Zoom sessions or send me an email if you're a little confused on this. Hopefully it's not too bad though. And that's it for Lecture A. I'll see you next time.